Hey guys, my name is Julia and I'm one of your teen services librarians over at the main library on Goodwood. We are back this week and we are testing our engineering skills because we are building toothpick bridges. Supplies that accompany this video are available at the main library's drive-thru in a limited capacity. To make a toothpick bridge, you will need something to cut with, Q-tips, glue, a pencil, some tape, toothpicks, plastic wrap, and graph paper. Our first step is going to be to design our bridge. We're going to build a truss bridge this week because their design is most conducive to toothpicks. I enclosed a printout of common designs for truss bridges, which you can follow if you choose. However, if you want to go all out and design something totally original, that's cool too. So our first step, we're going to start sketching our design on the graph paper. And what we want to do here is we want to copy two sides of our bridge on the same sheet of paper, so you only have to wait once while the glue dries. As you can see, I chose the Baltimore design for my bridge, and what we're going to do after our design is all sketched out, we're going to take our plastic wrap, cover it up, and tape it down to the table so it doesn't move. What we're doing here is making sure that we don't glue our bridge to the graph paper. That would be unpleasant to work with. Once that's all taped up, we're going to get our toothpicks out and start overlaying them on our pattern. To build the bridge, you can trim it to size if you need to. And we're going to lay them out across our pattern, our design, and start gluing them down by applying the glue with the Q-tips. One helpful tip is that doing this in piecework is really useful. So I have glued all these parts together right now. I'm going to let them dry, come back and work on some more. Everything is all glued up, and right now I'm just waiting for things to dry so I can flip it over and glue the other side just to make sure everything's bonded. What I'm doing in the interim is I've set up what will be the connectors for the top up here, and I'm going to get those glued together. We are all dry, so we're just going to go ahead and flip these over and start gluing the other side. Full disclosure, I totally did make sure that they would flip before I did this on camera, so expect a little more of a struggle bus when you flip yours. And this isn't quite dry yet, so we're just going to leave that alone for now. We're back again. Both sides of our bridge are now completely dry. This is already dry, our top is, and as you can see, I have glued up what will become the bottom as well. What we want to do now is we want to affix the top to the sides. All right, and after all that struggle, it is on there. So we're just going to glue it up now. Now that the top is dried, we're just going to go ahead, flip this over. We're just going to go ahead and put that bottom on right now. The bottom of our bridge is now dry, and we have created a truss bridge. Okay, so now it's time for the science. I'm going to apologize right now because there's a lot of terms coming your way fast and furious. The first is that stress and strain are not the same things. Stress is the force applied to a structure, and strain is the disfigurement or displacement that results from the stress. There are lots of different types of stresses that can go into it, but three important ones are tension, compression, and shear stress. Tension is a pulling force. Compression is a pushing force, and shear is when something is being pushed in two different directions. There are a whole lot of things that engineers have to take into account when they build bridges, but there's two things we're going to focus on today. The first is that you want your bridge to undergo as little shear stress as possible. Shear stress is how things like this happen. The second is that you don't want to cause too much strain on your bridge. You want to balance out the stresses as best you can, because too much strain will deform your bridge, which will collapse it. All right, so this brings us to truss bridges and how they work. The entire idea of a bridge is to be able to balance out the tension and the compression so that over a distance, the weight of the bridge and the load that will be carried can be spread out and hold. Trusses allow us to do that. The vertical trusses manage the compression stresses, and the diagonals manage the tension stresses. And this is how our bridge manages to work. If you guys have any questions or comments about today's video, holler at us. Our phone number is 231-3770, and we read the comments on these videos, so you can definitely leave us a message there. More importantly, show us what you built by tagging us on Instagram. Thank you guys so much for tuning in, and I cannot wait to see you next week.